Godot 4 is getting closer and closer to release, and it has a number of great features that I've been looking forward to for a while. Because of this, I decided to take the plunge and upgrade my C# game, Gun Game, to Godot 4 before my project gets any bigger. As a quick reminder, Gun Game is a fantasy roguelite shooter where you create powerful and unique builds every run. In Gun Game, you forge your own guns from a wide variety of parts and collect game-changing passive abilities to create the ultimate monster-slaying hero. If the game sounds interesting to you, check out my other devlogs in this series and consider subscribing to the channel to stay up to date. I am using C# to create Gun Game, and Godot 4 comes with a lot of big C# changes. In this devlog, I'm going to slow down a bit and go through a lot of the technical detail about the upgrade process. I'm doing this in case you find yourself in a similar situation and need to upgrade your C# project. Hopefully, this video can help you in some way. For everyone else, I think this more technical devlog will be great at illustrating how game development can be a not-so-fun slog sometimes. Why did I decide to do this upgrade? I wanted two big features, the canvas group node and 2D lighting improvements. Lighting performance is vastly improved in Godot 4, and I want to make heavy use of lights in my game, so upgrading was necessary. The addition of canvas groups will also make it easier for me to implement various visual effects as well. Before I actually started the upgrade for Gun Game, I needed to update some libraries I am using. These libraries are my Godot Utilities C# package and my custom add-ons called Godot add-ons. Both of these are available on my GitHub. I won't show the upgrade process for these projects here, but doing those upgrades constituted the first couple hours of my upgrade to Godot 4. I should also mention that the .NET 6 SDK is required to be installed in order to use C# with Godot 4, so I got that installed before starting. Then I opened up the Godot 4 project manager and imported Gun Game. I chose to let Godot do some upgrades itself, then I clicked into the project to open it in the editor. The first thing I did was add the .godot directory to my gitignore. It's recommended that you do this, presumably because this is a directory for caches and other temporary or transient data. Then, the moment of truth, building the C# solution. The beta announcement recommends that you let Godot regenerate your C# solution, so I deleted my solution and CS project files. I then got stuck for a bit trying to figure out how to have Godot generate the solution. Eventually, I found the option to do so under Project, Tools, C#, Create C# Solution. I clicked Build Solution, and 506 errors were reported. The only way forward at that point was to fix all the compilation issues. I knew fixing the compilation issues alone wouldn't fix my game. Once the compilation issues were solved, I was still going to have runtime issues and crashes to fix. I started going through the errors. Up first, the notification and process methods accept new types for their arguments. For the notification method, it now takes a long as an argument rather than an int. Also worthy of noting is that some notification constant names have changed. For example, notification instanced became notification scene instantiated. And similarly for the process method, it now takes a double as an argument rather than a float. I was using some visual server functionality to manipulate the game window, and some of those APIs have changed. For example, setting the window mode is now slightly different. Throughout the game's code, I am overriding the unhandled input method. When you do this, it's recommended to mark the input as handled so that the input event does not continue to propagate through the tree. This slightly changed as well. Rather than the set input as handled method existing on the scene tree, it now exists on the viewport. As a result of the delta value in the process method now being a double instead of a float, everywhere that I was using the delta value for calculation needed to be updated. The math needed to be changed to either be done with all doubles or the delta value needed to be cast to a float. I opted to cast the delta value to a float in every case because that ended up being the easiest. Other minor API changes caused some friction. For example, the perpendicular method no longer exists on the vector2 class, so I had to change my code to use the orthogonal method instead. Raycast queries against the 2D direct space state now accept a query object rather than a long list of parameters. This is a welcome change and should make querying physics a bit nicer. Curves also had their interpolate and interpolate baked methods changed to sample and sample baked. Noise was changed quite a bit as well. Open simplex noise no longer exists, so I had to use fast noise light. It has basically the same functionality, but seems much improved and more easy to reason about overall. Perhaps the biggest change that affected much of my codebase was the introduction of callables. Callables are objects that hold references to a function that Godot can call for things like tween callbacks and signal handlers. I'm sure that's an oversimplified explanation, but that's how it appears from my perspective as a developer. Signals drastically changed in Godot 4. Let's linger on them a bit and explore the numerous ways to use them. In C#, signal names are now required to end in event handler. This is because Godot uses source generators to automatically generate constants for your signal names. You still define signals using the signal attribute like in Godot 3. With the signal updates in C#, you can now connect to signals in multiple ways. New to Godot 4 is the ability to use the C# style event subscription, which is done with the += operator. The handler you use to subscribe to the event simply needs to have the same signature as the delegate you defined for your signal. You can even use a lambda function handler if you want. The other main way to connect to signals is using the connect method. Remember how I said Godot now uses source generators to generate constants for your signal names? When you use the connect method, you can now use a signal name constant as the first argument. Previously in Godot 3, if you wanted to connect to a signal, you would have to use a string or the name of operator. The second argument that's required in the connect method is a callable. Now is probably a good time to go over all the ways you can use callable. This is the way that callables will be used automatically after your project is upgraded by the Godot upgrade tool. This callable just points to the onDied method in the current class instance, but I would prefer not to use the name of operator if possible. So what are the other ways I can use callable? The callable class has a static from method with a bunch of overrides. Let's see the various ways this can be used. You can simply use your function name within the from method. If your function has arguments, then you can specify the types of those arguments, like with a boolean in the second example. Or you can define a lambda function that then calls the method you want to call with the appropriate arguments. As long as you pass in an action to the from method that matches the given argument types, then you'll be good. Needless to say, this flexibility is going to be really nice when working with signals and other contexts where callables are necessary. Let's return to signals. When connecting a signal via the connect method, the second argument passed can be a callable using any form you like. You can use the form shown in the first example, or you can use one of the previous callable examples. Sometimes you will need to pass binds to a signal handler. How can it be done? It's pretty simple. You just need to make sure to handle the signal arguments, and then you can call a second function with your additional parameters. In this example, I am accepting the area 2D that is sent as an argument with both the area entered and area exited signals. I am ultimately ignoring this area 2D that is sent with the signal though. Instead, I am passing my own arguments of 1 and -1, which previously would have been considered binds. Needless to say, these callable updates created a huge chunk of work for me, and no doubt for your C# project as well. Thankfully, the Godot upgrade tool does a pretty good job of making it work. But I still want to change the way I am connecting to the signals throughout my game so I can avoid using the name of operator. With callables and signals addressed, I moved on to other minor API changes. The update method was changed to queue_redraw, which makes far more sense in my opinion. The character body 2D replaces the kinematic body 2D and now has a built-in velocity property, so it no longer returns the remaining velocity from the move and slide method. Strangely, the Godot 4 upgrade tool renamed a collision shape to shape 3D. That puzzled me for a bit, but was a pretty easy fix. Rotation degrees no longer exists as a property on node 2Ds, so I had to update every location in the code where I was doing rotation calculations. Since rotations are done in radians only now, the deg2rad function came in handy in those situations. One of the biggest changes to Godot 4 was the tile map and tile sets. It changed so much to the point where my old tile map didn't even get ported. I had a lot of custom tile placement code that was designed to make creating tile maps in Godot 3 easier. that code no longer worked. Rather than try to figure out how to interact with the new tile maps through code, I just removed this section of my code. It wasn't serving much of a purpose anymore anyway, and I was hopeful that all of my needs could be met with the new tileset editor. I previously mentioned that I have a library of C# utilities I use for Godot game development called Godot Utilities. One of the nice features of this library is the node attribute, which uses reflection to automatically assign nodes, so I don't have to use getNode everywhere in my code. However, since this relies on the name of the node in my scene to do successfully, every time the Godot 4 upgrade tool renamed a node in one of my scenes, this reference became broken. One of the most prominent examples was the rename of Sprite to Sprite 2D. This was a simple fix, but I was sure I was going to encounter this issue again. Control nodes underwent a pretty big overhaul as well, so every place I was referencing the previous rect position, rect global position, and rect scale properties in code was broken. Control node properties are no longer prefixed with the word rect. At this point, the compilation errors were almost done. There were a few more minor changes that were as follows. The file class was renamed to file access, the dir class was renamed to dir access, the partial modifier is now required on classes that extend Godot objects, but the upgrade tool missed adding this modifier to my abstract classes. The reference class was renamed to ref_counted. With those issues fixed, my game compiled successfully. But of course, this was not the end of the journey. It was time to discover all of the fun runtime issues. I ran the project and the game crashed as expected. The cause of this initial crash was a shader compilation issue. It turns out that a shader hint I was using no longer exists in Godot 4. In Godot 3, you could use hint color after a vec4 uniform to get a color picker. This did not appear to exist in Godot 4 at first. I searched online for a replacement hint for quite a while before I came across this thread from another frustrated Godot user. The thread was entitled, "What the hell happened to hint color in Godot 4? It turns out that this hint was renamed to source color. The name seems questionable, but inserting that into my shader fixed the issue. My game was still crashing after that fix. I wasn't entirely sure what was causing the crash at the time. I opened up the Godot log file and saw that there were a bunch of parse errors. The first error in the log was related to broken audio stream references in my gold scene. I decided to temporarily remove the broken audio references in hopes of fixing the issue. I ran the game and was surprised to see that there was no more immediate crashes. Unfortunately, as you can see, the game was still not in great shape. I noticed a lot of runtime errors being printed to the console. Many of these were caused by a null reference caused when I was calling getLastSlideCollision on the new CharacterBody2D class. This method returns null if there was no collision on the last frame, which I was not handling properly. Fixing that was pretty straightforward, and running the game again revealed only 7 errors. Most of these errors were of the format condition proxy.isValidIsTrue. This seemed related to viewports, since the error was referencing viewport.cpp in the error message. I had a hunch this was related to my assembled gun scene, which uses viewports to render guns. I decided to skip the error at that moment, since it wasn't causing a serious malfunction and there were other, more pressing issues to address. One really strange issue that was related to the rename of Sprite to Sprite 2D was that a node named Navigation was renamed to Node 3D. I have no idea why the upgrade tool thought this was appropriate, but again, this was a simple fix. With that error resolved, I moved on to investigating an issue with some of my signal handlers. I was getting a method not found issue, which typically means that a signal handler isn't set up correctly. However, after some tinkering, I discovered that Godot was unable to call signal handlers where I had specified object as my parameter types. I was using this object parameter type throughout the codebase to handle throwaway signal parameters, since sometimes there are arguments emitted with a signal that a handler may not need. Godot requires that your signal handler have a number of parameters that match the signal definition, however. So I updated every instance where I was using object types in signal handler parameters, and those method not found errors disappeared. I had addressed the vast majority majority of runtime errors that were printed to the console, but there were still remaining soft errors. In other words, errors in my game's behavior or functionality. One of these was the inability to move or shoot. I have an input manager for the player, which seemed to not be working at all. After some investigation, I discovered that all of my custom input map actions were completely broken. I also promptly discovered that defining actions is now much improved and much more flexible. I rebuilt all of my game's input actions using the new system, expecting my player to be able to move after that. And movement still didn't work. One thing that seemed strange to me was that my player input manager node was grayed out in the scene tree. This seemed to indicate something wrong or different about the node, but I couldn't figure out what it was exactly. I ultimately deleted and remade this node in an act of desperation, and then looked at the diff between the scene files. There it was. The process mode setting was what was causing the issue. It turns out that one other major error the Godot 4 upgrade tool made was migrating the pause mode for nodes. In Godot, you can define a node's behavior when the scene tree is paused. Nodes can be set to run or to not run when the scene tree is paused. You can also specify a few more specific options for pause behavior. I had some nodes in the game configured to always run when the scene tree was paused. The upgrade tool migrated these nodes to only run when the scene tree was paused. This is indicated by process mode equals 2 in your scene files and the grayed out look. The upgrade tool should have set it to process mode equals 3 to match Godot 3 behavior. Once again, the fact that Godot's scene files are all text-based meant that I could just do a project-wide search for process mode equals 2 and replace all of the occurrences manually. With both the input map and process mode issues fixed, input began working again. I was able to move and shoot with no issues. The next set of errors I encountered were related to animating control nodes. As mentioned previously, control node transform properties are no longer prefixed with rect. Anywhere I was animating these properties, either with an animation player or with a tween, had to be updated. I did a search throughout my project for any occurrence of rect underscore. I then replaced everything with the proper property names. As mentioned before, there is no longer a rotation degrees property on node 2Ds. There is only a rotation property which is in radians. I had to painstakingly go through all of my animation players that were animating rotation and update the value in each keyframe. The most complicated animation to update was my spider centaur, which has a lot of moving parts. The next issue I encountered was an issue with the setState method in a state machine class in my Godot utilities library. It turns out I was using call deferred incorrectly. A quick fix there enabled enemies to start spawning in the game. I encountered another issue caused by the idle frame signal in the Godot 3 scene tree being renamed to process frame in Godot 4. I decided at that point to fix the condition proxy.isValidIsTrue caused by viewports in my assembled gun scene. I removed the viewport from the scene and switched to a canvas group, which dramatically simplified the node structure. However, the canvas group rendered as a white square after adding a shader material. It wasn't until a few days later, after I reported an issue, that I was alerted to the fact that this was expected behavior and I needed to use the screen texture and screen UV shader constants when writing a shader for the canvas group. Although I initially thought this was broken, I was able to fix it at a later time by simply updating the shader. Another visual issue I encountered was texture filtering. Godot no longer contains texture filtering options in the Import tab, which is where they were located in Godot 3. Instead, texture filtering is now a project-wide setting, with individual textures being able to have their own filter overrides on the Sprite 2D node. I set the filtering to nearest at the project level, which is the setting to use for pixel art, and immediately all my art was back to normal and looking good. A very easy to miss change in Godot 4 is the ability to specify a mode for character body 2D, which was previously kinematic body 2D. Now you can specify the mode to determine whether the character is grounded or floating. My understanding is that the grounded mode will do floor and slope detections, which are useful for snapping in platformer style games. The floating mode is more appropriate for top-down games like mine, so I made sure to change all of my entities to use the floating mode. An exciting new change I discovered is this change in the rendering settings, which allows snapping 2D transforms to pixels. In Godot 3, this was called GPU Pixel Snap. However, This new setting appears to affect the game camera as well, which finally solves the classic jitter issue many people experienced with cameras and low-resolution 2D pixel art games. Fonts have changed a lot from Godot 3 as well. It used to be the case that if you wanted a font with an outline or of a different size, for example, you'd have to create a new font resource. As you can see, I had a lot of different fonts. With the upgrade to Godot 4, these font resources were all completely irrelevant, and the fonts throughout the game were broken. To fix these issues, I just needed to define my main font. All font sizing settings are exposed through the UI now. I changed the theme-wide default font size, and then was able to change the font size individually for my multiple label variations. Outlining works in the same way. You can now define outline settings on a theme or control node level, rather than needing to set outlines on the font resource itself. Something that happened in my project after the upgrade was my theme type variation selections were broken in some instances. For instance, here, I have a bold label variation, but this was erased after the upgrade, so I had to go into my node and reselect the proper variation. I started the project upgrade on Godot 4 Beta 7, but since I thought canvas groups were broken, I decided to upgrade to Beta 8 to see if that issue would be fixed. Instead of fixing an issue, however, Beta 8 seemingly broke exporting arrays of packed scenes in C#. I had to fix this by exporting the Godot collections array type instead. Of course, there was the elephant in the room to address. My tile maps were completely erased. I actually had no clue even how I would salvage them. So I decided I would just rebuild the tile set from scratch. Godot 4 makes massive changes to tile sets. I have to honestly say that the tile sets are a usability nightmare. Settings are scattered across the tile map node and the tile set itself. It's not at all clear how to use the tile set without referencing a tutorial. And the difference between the tile set and the tile map panels at the bottom is not clear at first glance. But these new tile sets are super powerful. What I previously could only accomplish using several different tile maps, I could now achieve with a single tile map. I can stack different collision shapes on different layers of the tile map. I can have floor elements like rugs that sit on top of the base floor tiles. I can add individual details like shadows. What this new tiling system lacks in usability, it makes up for in raw power. I still have a lot to learn about this new system, but I was able to get the dungeon tile map rebuilt and looking really good. Alas, this was not the end of my upgrade journey. Up next in the long list of issues were problems with particle emissions. Basically, what I discovered was that any randomized particle parameters were not upgraded by Godot. Anywhere I was using initial velocity, angle, angular velocity, and particle animations had to be manually updated. These parameters now all have min and max values, which is far more intuitive. Previously, randomization in Godot 3 for particles was done on a 0 to 1 scale. I was able to speed along the particles update process a bit by copy and pasting various particle properties in the scene files. This process still took a lot of time. Perhaps the thing that concerns me the most about this process is that I am sure I missed updating particles somewhere. I make heavy use of particles, and I'm not confident that I updated all of the particle properties in all cases. Another issue with particles that I couldn't fix myself was that they cause massive screen artifacts when using the explosiveness property. This is an issue that at the time of this video is actively being worked on. It is very annoying that every time I shoot a gun, then I get weird texture flashes on screen. I'm completely confident that it will be fixed though, so I'm fine ignoring it for now. Because of the changes to various control node properties, much of my UI ended up being broken. For example, my ammo bar was no longer expanding in the horizontal direction as expected. After some tinkering, I remembered that the crux of this issue was the fact that rect min size was changed to custom minimum size. Updating this value across many of my UI scenes enabled the UI to function properly again. I had the same issue with my animated card scene, which is used for player passive upgrades and gun part selections. There were also a couple of minor label alignment issues, which were easy to fix by simply changing the vertical and horizontal alignment. After fixing those issues, there was one final thing that I needed to address, and that was that my character was slowing down dramatically when colliding with walls. Initially, I was worried that the character body 2D changed in a way that would make me have to rework character movement. Instead, I discovered that the character body 2D now sets its own velocity after it collides with something. I was incorrectly taking the remaining velocity and then overriding this character velocity myself. Removing that line restored the natural sliding behavior that I was expecting. Then the unthinkable happened. The update to Godot 4 was complete. There are still a couple of minor issues that I need to address, and I have another tile set to rebuild. The upgrade process was pretty painful, but I'm glad it's over and I'm excited to make heavy use of the new features. According to my video footage, the upgrade process all in all took me about 10 hours. This video ended up being very long and very technical, but if you made it this far, then I hope you found it entertaining. And if you're upgrading your own C# project, then I hope you found some helpful info in this video. Subscribe to stay up to date with Gun Game, and I will see you in the next video. Thanks for watching this video. Please consider liking and subscribing. Check out the links in the description to sign up for my email list at firebelly.com to learn how to build a 2D platformer in the Godot engine, and to support my work by purchasing one of my games on Steam or itch.io. All those links are in the description.